Good morning and welcome you all. I, Dr. Pradeep Tiwari, subject expert of understanding PC and troubleshooting. Today, our first lecture and last lecture was the zeroth lecture. We have discussed about this, and today we'll discuss the first topic, and we can also say first unit of your subject understanding and troubleshooting. The topic is CPU. The electronic circuitry that execute instruction in a computer program is known as a processing unit CPU. It can perform the operation like arithmetic, logic, and also it can control the input and output task. These are things managed by the CPU. So, what are the objectives? The objective of our this topic determine the CPU most important features, learn about the several principles of modern CPU, classify and describe the CPU in detail, explain the concept of CPU overclocking, perform overclocking on the various processors. These things today we will going to discuss. So first, what is the CPU essentials? So typically the buses, the most popular method of data sharing, and data is transferred across the all devices connected. Buses are also known as processor signals. The first question arises our mind ki how the CPU interact with the different devices at that time. Here we can hear the interaction of the CPU via the buses. Buses can transfer the signal from all devices. We can also say the buses CPU uses the buses to transfer the signals. In here, CPU have a three classification categories. How it can transfer? So we have three major categories. The first one is the data buses. Second one is the address buses, and third one is the control buses. So in our next slide, we will discuss about the one by one. First, we will discuss the data bus, then we will discuss the address bus, then we will discuss the control bus. So first, we are going to discuss the data bus. There are three major categories. The first is one is the data buses. What are data buses? Data bus perform and transfer the information on the CPU. It is handled by the buses, and we can already we have because how the transfer the information CPU. The transfer is sharing the information by the buses. Okay, it serves as a benchmark for CPU performance because if they are transferring the data, they are performing a transport service. If we have a transport service faster, it means we have a little bit get the better results. Same here, if we want a CPU performance good, that time buses should be able to send the messages from to the devices. The device is used to transfer information from CPU to RAM, ROM, input unit, as well as between timing and control buses informations. So buses can transfer the information and random access memory, read only memory, input output devices like a monitor, like a printer, etc. And it can also manage time. What is the meaning of time and control? Timing, because we have managed the CPU in MIPS, and also here we are CPU sending the message. I am the main role of the MPS, million instructions per second. These million instructions per second, how we can find? We can find either because we have heard about the CPU gigahertz and megahertz. That this is the power. And when how many and it is dependent on the clock. How many clocks are working in a particular amount of time, and in a per certain amount of time, how many instructions are executed. These instructions are executed. These mapped by the MIPS, million instructions per second. Okay, and the forecast is made the specific period of time sufficient to take the decision and put into it takes how many times. And you have seen during the when we are copying some things, if the size is 1 GB or a 2 GB, that time we are seeing the how many times is going. This is the forecast time, how many times CPU will take to copy from one pen drive to the another pen drive or a pen drive to the CPU. Same here, if we are working any task, that time it takes the calculate the time and forecast is how many time is going to calculate. You have also seen if we have inserted two pen drive, one pen drive that is showing only the 1 minute or 1.5, maybe it we are assuming this is the time copying will be data from pen drive to the CPU, pen drive to the hard disk. If we are going to pin another pen drive and we are copying started from the second pen drive to the hard disk, that time we will see the first time was the 1.3 minute exceed into the 5.1.7 1.8, because currently we are using the 2 pen for copying in a hard disk, so the forecast time will be increased. Okay, also it takes the historical information data, how many times will we have taken to particular perform the task, to now this time will take by the CPU. So buses are playing a vital role, key roles for sending the information from CPU to the other devices. If the buses are faster, that time we will get the better results. Why we will get the better results? Because maybe I am giving the analogy. Suppose that I am speaking in a very faster manner, and you are all not able to hear it in a proper way. That in this faster manner, that time it is good. No, same here, if the CPU is faster but transporter is not good, then what will happen? So here the role of the buses, if the CPU works in faster manner, that time they can also send the information to the devices in a faster manner. The next one is address buses. What are the role of address buses? Address buses carry the specific address of that particular data rather than the actual data. It means address buses, what are the doing addresses? Address buses is going to take information in a particular address. It's not means they can put the data in any place of the memory. So address buses carries the data from the specific address and a particular address, and they can measure the terms of address line by address buses. Here there are I'm giving the examples. When you will learn the operating system, that time you will get there are some pages, and pages is counted by the lines, one line, and also if you are making the program, that time there are several lines. So how many address lines are working, and there are address line, they have a specific address positions. So buses can measure, and they can address buses can measure, and then they can transfer data, and they can also take the data. The CPU address buses line of 10 maybe address up to 10 equal to 10 1024 bytes, for example. So here is an example, and I am giving the example. What is the address line of 10? If you are doing the 2 power 10, what you will get if you are doing the 2 power 10? 1024 bytes. How we can calculate? If any line here, the memory calculation is on a power of 2. So when you are doing the any address space mapping, that time you will get the power of 2 calculations. I am giving here example. You always hear about the 2, 4, 8, 16, 16 bit, 8 bit, 32 bit, 64 bit, 128 bit, 258 bit, 516 bit, 1024 bit, and it also is calculated in byte manner, GB manner, and KB manner. So here we can see the all these calculation going to the power of 2. Okay, you never seen 9 bit, 11 bit, 13 bit of memory size. If you are going to purchase, that time the memory slot always be the 16, 32, 64, 128, 256, 512, and 1024. So here we can calculate is And if a prefix come use the address of line, suppose that we have a 10 address line, we can say A0, A1, A2, A3, and it's going to the A5, A6 and A numbers. So if we want to go address line 1, that time it will go for the A1. If we are going for that line 5, that time it will go for the A. Next one is control buses. So what are the control buses and what are the role of the control buses? So timing and control buses, another name for the buses. It utilized to coordinate and control the CPU functions. So it can coordinate, it can control the functions like arithmetic, logical operations, and it can take the output and transfer it by using the address buses in a particular place. So, and the various signals are read, write, interrupt, acknowledge, parity checking, cache operation, power control management, all things done by the control buses. Okay, it's also a part of a how to write, how to read, how the interruption is called during the working, because the CPU is a central processing unit. It can perform the task and it can perform the task in a many manners like a shortest job first, FCFS, first come, first serve, round robin. There are some mechanisms to of a CPU that can working in a different processing. So here, how to manage the read, how to manage the write operation, how it can manage the interrupt operations. These things are managed by the control buses. Here is a table. Here we can compare what are the role and responsibilities of these three categories: data buses, address buses, and control buses. So here in a figure, we can see. Here we can see. This is the buses transfer unit. This is the CPU. Here is the one part of bus transfer unit. Here is the arithmetic logic unit and timing and control unit. How these are things managed? So here you can see the address buses control the input and output operations, and control buses are connecting the information from ROM and RAM. Here one way, because always we are taking the information from ROM read only. Here we can store the data permanent. So we can't submit the data or store data at place. So here is a one way arrow, and in RAM we are can take and we can also put. So here we can see the double sided arrow, and also in a input and output devices we can take and give the informations. So what is this thing? Transmit the instruction to CPU from memory for execution is done by the data buses. Okay, here we can see that transmit the instruction from the CPU via the data buses. Here we can see this is the data buses, and here we can see this can transfer the information from CPU. Carries the data or operation. It can also carry the data for the operations. In address buses, transmit address and memory before any instructions or data can be written. So what are the doing by the address buses? They can transmit the memory where we are going to store the data. This is the main work of the address buses. And next one is the control buses. We have already understand read write operations, carry individual signals, coordination, control. These are things done by the control buses. So now it is here what is the role of data buses, the role of address buses, and what is the role of control buses. In one line we can see of the data, identify of the information, and control the operation done by the control buses. Here, what are the doing the CPU? Because we have multiple CPU and multiple types of the CPU like single CPU, quad core processor CPU, and hexa core CPU. There are multiple central processing units and they have a different type of a working categorization. So here, what are doing? What are the modern CPU concept? How they are different from the older one? So here we can see the central processing unit control the unit, regulate and integrate the computer's operations. CPU can manage and CPU can manage the different operations, memory management, process management. These are work operating system will handle by the CPU. Because the main key role of these things is the operating system. Operating system is the hardware, CPU is the hardware. If they have a function, so operating system can perform na operation. Only software cannot do nothing if the hardware do not have a capability to doing something. Okay, so here are some main features of the CISC and RISC CPU. Second is circuit size and die size CPU, processor speed, processor cooling, system clocks, architecture, performance and features. These are enabled in a modern CPU. So here the part is divided. What are the roles CISC and RISC? CPU size, circuit size, die size, processor speed, and why we need processor cooling. What is the meaning of system clocks and what are the architecture performance of the features? So we are going just one by one these topics. Here first we are going to discuss the RISC and CISC. What is the meaning of RISC? RISC is the reduced instruction set of computer. How to reduce the instruction set of computer, and CISC is the complex instruction set of computer. So if anyone asks what is the meaning of RISC, that time you have to say redundant instruction set computer. In a CISC you have to say this is the complex instruction set of computer. Next question is, this is the full form. They are working, so they are emphasizing on software to optimize the instruction set. When we want to the do of the optimization work, that time we need the RISC. What is the meaning of optimization? Making the performance better. Utilization of a CPU in a better manner, it is the optimization. And here the CISC complex hardware to optimize. So here in a RISC we are talking about the optimization of instruction set of the software, and in a CISC we are talking about the hardware. The second different optimization of the hardware, CISC optimization of a software by the software. This is the RISC. The hardware unit programming in RISC processor. It is a programming which is in a processor, and this is the micro programming. Also, it required the multiple register set to store the instructions. Here we require the multiple registers to store the instruction. Here require the single register. Single register. What are the work of the single register? Like a yes, no, on, off. These type of work performed by the single registers. And RISC can be simple decoding the instructions. It is the complex to decoding the instructions. Pipeline are simple in RISC, and pipeline are equal to. What is the meaning of pipeline here? Here when we want to transfer the information from one device to another, that we have a pipeline. It means the buses are using the lines to sending the transfers. It's sending the transfer the information. And use the limited number of instructions that require the less time to execute the instructions. So it's are taking the less time. Here large instructions, and also it is using the single bit register, so it takes the more times. And the example of RISC is ARM, RISC, Power Architecture, Alpha, ARC, and Sparks. So you have a ARC system. So these are Power Architecture managed by RISC, and the Motorola 68,000 system 360 AMD and Intel 86 CPU is the example of the CISC. So if anyone asking what are the difference between what are the example of a CISC and RISC, that time you can say the model of family AMD and Intel are using the CISC for managing the complex instructions, and it is the hardware. So here you are seeing the what is the AMD is a hardware, Intel CPU is a hardware. So here we are talking about the how to manage the power architecture. So we are managed by the software. Okay. So here we are talking about the software things. After CISC and RISC, there are another important topic is circuit size and die size. What is the circuit size? What is the meaning of circuit size? Scaling the processor model or drawing the meter of the processor is equivalent to the circuit size. So what is the meaning of a processor model? Where if we are using the any processor model or a drawing structure, तो उसका जो when we are using this time the circuit size will be the equivalent to the processor, and more transistors which are smaller are necessary to produce the powerful processor. So here the smaller transistors can, nowadays we are using the powerful transistors to produce the powerful processors, and it can reduce the size of circuit and we will get the powerful system. And here we are using the how we are reducing the size we can map by the micron. Okay, so here is the what micron size we are using. Recently we are using 1 to 1.8 micron. So it is the circuit size. And you have already heard in a fundamental of computers now, the first generation computer system is using the what using? They are using the bulb. Vacuum is for the vacuum tube. Then included that time we are using integrated circuits. Nowadays we are using the artificial intelligence. So IC is an integrated circuit, is a more powerful make to the system rather than other things. Next one is a die size. What is the die size? Die size is a physical surface. Die size is a surface and it can also be the area of a chip. So we are, if we are going to the market, we are where the circuits we are putting, this is the die size. Okay, and this is measured by the square, measured by square millimeter. Okay, and first constructed the silicon. First constructed the silicon, referred as silicon wafers, and this wafer is called die size. This is belong to the die size. This is smaller. If the smaller size of the wafer, closer the components arranged with the increase the performance. If smaller time we will put the things in near, so we'll manage easily. If we are taking the die size greater, that time they can take larger size and they cannot perform the better. Smaller size will also help to the more chips in a single wafer and reduce the manufacturing cost. So we have already discussed what is the role of the die size, and it is reduced. And if we are using the smaller die size, we can manage things in a smaller time. That time power consumption is also reduced. Now more which we have discussed: processor speed and processor cooling. What is the meaning of the processor speed? Why the processor speed should be higher? So here I am going to give one analogy. What is the role of the processor speed and why we need the processor speed higher? If suppose that if we are running in a track, walking in a 4 kilometer per hour, time we will cover only the 4 kilometers. If we will walking in a 8 kilometer per hour, that time we will cover the 8 kilometer track. If we are walking in a 16 kilometer per hour, that time we are walking, we can walk in a 16 kilometers. Why I am giving the analogy? It means when we are running first, that time we will cover the after. Here, same here. If processor speed is higher, that time it can calculate the many things in a particular amount of time. What particular amount of time? Million seconds. How many can map the speed of a system? Million instructions per second. How many million instructions per second CPU can execute? It also depend on the CPU. Gigahertz can make the CPU gigahertz in a megahertz. Okay, so if the CPU process speed is higher, that time it can calculate the multiple instructions in a particular amount of time. Like if we are driving the car, if riding the bike, if we are taking the accelerator more time, the more highway in a certain amount of time. Here, if the CPU is a more faster, that time it can calculate the multiple instructions in runtime. Here, suppose that this is the CPU, it process. If it is working in this manner, so it will cover. It will can only cover the job, and it can take only 100 instructions, 200 instructions. It is running faster. That time it can take the multiple instructions. So CPU should be higher. And another one is a processor data refers to the processor speed. If we have the processor speed, that time it can process the multiple data. Ability to run application is dependent on processor speed, which measured in a gigahertz. So also it application, how it work perform and how it is going. What is the meaning of server down? Server, we are already heard about server down. It means the processor is not running in a proper speed. That time it is not able to handle the multiple users and all. So what is the desirable? We have desirable the faster processor. So when the processor is running in this faster manner, that time it generates the heat. If it generates the heat, and you have seen the CPU, there are a multiple. If CPU will generate the heat, that time this heat can affect the device like RAM, ROM, motherboards, and all these things can be affected by the heat. So what we have to do, that time the CPU, you have seen the CPU. When you are seeing the desktop computer, then in a desktop computer we have a one box. Okay, and this box we are saying the CPU. No. This box is not a CPU. This box is a cabinet. In a cabinet we have one component: CPU, RAM, ROM, buses, and motherboards. But the CPU is a powerful, so we are calling this cabinet as a CPU. Okay, please take the CPU. No. There are a CPU, and you have seen in a CPU background there is a fan, and it fans running when we are using the system. In a laptop, if you are left hand side and right hand side, it's depend on if you can take your hand in the side of the laptop base, that time you can see, you can feel here is some fan. It can in the air to the outside. Why we are these things? Why the CPU is doing this? Because this heat can transfer from the inner to external. It will put live in a inside the laptop cabinet. Then it can generate and it can damage the other part of the system. System is RAM and buses, motherboard. So any device, because we are using the essential parts, they can damage by the heat. So it maintains the computer temperature limit. It can contain temperature limits. Computer is cooling is to remove heat created by the computer component, because it generated the heat and it can damage the system. So integrated circuits including the CPU, chipset, graphics card, hard drive, malfunction, permanent failure, overheated generate, uh, which we discussed before the 30 to 40 seconds. Why? Because these circuits, CPU, and any device can damage by overheated. So what are cooling? What the fan is doing? Or it can remove the heat and it can help to the system cool. It means here not a need case. Why we are not putting the no, the system is not need inside the system because they can, if you are reading what is laptop configuration, that time here they have mentioned this laptop is working minus 5 to the 40 temperatures because it is also internal and also the CPU can damage the external heat. Na? So if the external more than 40 to 45 degree, that time we also need the air cooling the system. These are called the precise. This is not like a they can generate the humidity, but the precise is not generate. They are generate the dry cooling. Next topic, an important topic, we have seen the system clock, and here we have already seen what is the system clock. And if we are going to the system shutdown, and when you are open your system, that time you are going, your clock is working. Your clock is working properly. How is this clock is working properly? We will discuss here. So here is a PC driven by system clock. So PC driven by system clock. If your clock not working and you want to go, for example, if you are going to open the Gmail and if your today we have a 9th December at 10:30 and if your clock is showing 18 the 11:30 or else any times, that time if you want to open the Gmail, that time it will show your system clock is not working because that time it matching your clock with his own clock. If you are not agree with me, please change your time of your system and you will see this type of errors. So PC's work is driven by the system clock, and also you have seen how many works are taken by the particular processor. But we are writing A, B, C like work and small calculation. Here we cannot see if you are working in a hard manner. If you are using millions and trillions lines of calculation, that time the system clocks will active and it will show the time. How much time will take by CPU. And next one is the cycle. What is the cycle? When I am explaining this, CPU it can take the instructions in a particular amount of time. So when it complete one round, that time this is cycles. And cycle map by the short unit of the time is the processing take the place. The process take the place and this process place in a MI plus million instructions per second. It's like we are saying the car and bike have a cc, 1000 cc, but when we are running in a 80 100 kilometer, that time we are showing we will cover 80 kilometer per hour in a region of 100 cc. If we are talking about 1.2 gigahertz or a megahertz, that time it can calculate MIPS million instructions per second. Now I think it is easy to understand. Why, how used to only system clock to drive the processor in previous PC, the speed of memory buses and motherboard is referred as the system clock. So buses speed, I told you, motherboard working is all also depend on the work mechanism. So it's also take the CPU. If the clock is take calculate the time, CPU is sending time, motherboard working time and CPU time all are calculated by the system clock. Next one is the architectural performance features. What are the architectural performance features? So, in performance is often described in instructions per cycles. How many cycles it is calculated? So MIPS, instructions per cycle, means MIPS, million instructions per seconds. A faster IC rate, it means computer is faster. We have already discussed previous slides, and they are measure the computer speed by the clock rate. And what is the clock rate? Megahertz and gigahertz. But it's mapped by the MIPS, like 100 cc bikes. We are running in 100 km per hour. Okay, if we have a 350 cc, that it means it can go faster rather than the 100 cc, maybe 120 150 kilometers per hour. Megahertz is in the clock speed is higher. We can perform the multitask in a certain amount of time. And sometimes this is called the, sometimes and always it is called the throughput. What is the meaning of throughput? In a certain amount of time, how many instructions are executed. Okay, a machine with higher clock maybe better performance. If a result manager have moved away the clock is measure the performance. The clock is measure of how the performance we calculate in MI. And things here we are going to discuss different type of process. So here we have taken the two processors to understand the processor and the working. How can differentiate processors? We to say we want to know system performance. That time we have to should know about the processor. So what are the procedure we are discussing? Here we are discussing the processor 8086 and 8088. So here using the 16-bit data buses, and here in 8088 we are using 8-bit. The meaning of 16-bit and 8-bit buses. We already when we are start this topic, if we have buses, address buses, buses. First is the data buses. So the data role, it can transfer from this place to the another place. If we have a 16-bit, means we have a more lines. It means we can transfer the 16-bit data at once go. At once go 16-bit data we can transfer from one device to the another device, and here we can transfer the data 8-bit. So we can understand 8088 is a more faster rather than the 8088 because of its bit speed, because of the transferring speeds. Here the clock speed is the 5 megahertz, 8 megahertz, and 10 mega. Different type of a model have a different type of a clock speed. 80862 using the 5 and 80861 using the 10 megahertz, and here is also the 3 clock speed and 8. So we can here see also have a 10 megahertz, and we have a more megahertz, more clock cycles in a certain amount of the time. It means we can say it is the more faster rather than the other systems. It using the it using the complicated memory control. It means its configuration architecture is more complicated rather than the 8086. It can read and write either 8-bit or a 16-bit word at the same time because it has a speed, and it can only read the 8-bit. Why? Because it has the data of the 8-bit. It has a 6-bit instructions queue. It has a 4-byte to 1-byte instructions queue. Here is a 6-byte and here is a 4-byte to 1-byte. Here also it is a faster queue. What is queue? If we are using CPU, that time if there are a multiple process, that you can run only one program, that time the other program will. So how many programs can go? There are, if they have a bit restriction, that time it can be in a queue, and it draws the maximum supply current 16 and megahertz, and it is 334. And the nowadays we are the only types of the processor in the market, Intel and AMD. Nowadays we are getting the also selling the processors, and people are nowadays interested in buying to the AMD. So if you have choice to purchase which system we have, Intel based or AMD based processor, so here is a base difference between the Intel and AMD. So here we have only 2 cores, and AMD have a 4 cores. So here AMD is a more performance rather than the Intel. And what is the course? Course is a management. If there are some processors, so processor working mechanism managed by the course. Here is the threads, 4 threads. Here is the 8 threads. What is the threads? Threads are a small programs. They are running by a kernel, and kernel is a part of the CPU. So if we have here only the 4 threads, here 8 threads, it has a greater performance ability. And how the threads working? Suppose that I am giving the examples how the thread is a more. When you are working in a MS, that you have seen, you write, suppose that A, B, C, D, and here is a blue line, here is a red line. Blue line shows there are some syntax, and there as a your word is not correct. So here you can see you are only performing the writing work. So one thread is you help to the writing, one thread checking the syntax error, and one threads are checking the errors. So if we have a multiple thread, that time we can perform the multiple tasks, and it's a simple small programs. Here in a kernel we are using fork, read, write, exit, and here is the base frequency 2.2. This here is 2.7, 3.5. It means it's working, performance is better. Here the bus frequency is equal. It means they can transfer the equal data. And here is a multiplexer. We have a 20x21. Date of the October 17, 2020. Here is a January 29, 2019. It is enabled in a laptop, and access is x86, and there is the code name Tiger Lake, and is known as the JAWS. So next, what is the x86? X86 is architecture model. What is the meaning of architecture model? It means if we want to perform the specific task, that time we sometimes need a specific architecture. Suppose that if you want to work in a image processing like work, that time you have to need the GPU rather than the CPU. If you are working in a numerical way, that time you have to need the normal Intel processors, AMD processor. If you are want to make your machine as a cloud machine, that time you have seen. If you want to check, you can check some books. They are referring one system in a cloud system. That time, while you can work, if you want to work, that time you have to use the x86 architecture and 64-bit. 64 instead on the 64. 64 is better good system. Nowadays we are using 64-bit systems, and also the software. Nowadays our software also depend on the how much bit system you are using. So there are software mentions. If you want to install 32 times, you have a type of system. If you want to going to work on a 64-bit system, and you have to install this. If you want to use, you can simply type Microsoft operating system for 32-bit, and Microsoft system for 64-bit, you will get the different type of system. And also there are multiple software, they are also bit size. Last but not least, here we are discuss the CPU overclocking. What is the meaning of CPU overclocking? We have discussed the clocking, but here we are going to discuss the CPU overclocking. It means taking the performance, taking the more performance rather than the available performance. It means if the CPU is running slow, that time we can perform the CPU by the because we can increase the uh, performance clock running time. So we can increase the what we can increase we can increase performance. So it is the common way of overclocking to improve the system performance. That time how we can perform the system? So we have used the four components: CPU, motherboard, system memory, and CPU cooling. If CPU working in a faster manner, that time it can generate the heat. That time we have to CPU cooling. It can also cool the CPU. And the second one is the motherboard is also able to capable to have these things, take the step perform, and system memory is also that we are increasing the clock size. It's running faster. That time it takes the instruction from the and RAM 218 or 518 or 512. That time it can take the only limited set of memory. I am giving the example of a real. Suppose that in our MS team we have only I can teach that this system can perform or my system perform multiple, and here I can teach 10,000 students in a one time. Yeah, if I want to see the student all 300 400 student in a single screen, but it is only able to show the 40 or 50 student in a single screen. That time what will happen? All to perform, I want to see CPU also. CPU have capability to and software, because software is not on that time. What can we see? Not see. And we are giving the example. Suppose that taking the class in a offline mode. Suppose, and in a, we have a only sitting capacity 20 students, but I have a voice. We teach 160 students. Can I teach 60 students at a time particular? Yes, I can teach because I have a capability to teach student at a time. But due to the space, due to the space of a limited space, we can only sit 20 students. That time what will happen? I will teach only the 20 students. So say the CPU is working faster, but we have a not RAM size is good. That time how we can put the take data and the, so here it will be the problem. So we are using here the so system memory, motherboard, and CPU is so responsible for overclocking requirement. Overclocking, we are taking the facility to using more. So what we have understand today. So in this topic we learn the various components of the CPU, three categories of the CPU, and we have also learned what is the risk and what is the risk. Uh, we have also compared what is processor king, why we need the processor cooling, system clock, what is the architectural end processor, that we have understand what is the rule of 8086 Pentium processor, how it is working, what is the meaning of core AMD processor, CPU clock is the requirement of the overclocking. These all things we have discussed. Here within a minute, I'm going to review. today we have learned about the determine the CPU most important features in principle of modern CPU, describe the interview details, CPU overclockings, and what is the meaning of overclocking and how we can perform. So here we have understand the three features: data buses, address buses, control buses. In a data buses, we have understand CPU can transfer the data from one device to the another device. In a address buses, where we have to put the data and how we can get the data and compare by the address line and address line by the A0, A1, A2, A3. Control buses control the various tasks, write operations. And here we have architecture of the address buses. In a modern CPU, we have the several features like a CISC and RISC, size, processor speed, processor cooling, system clocks, architectural performance features. And we have here understand CISC and RISC. RISC we have reduced the instruction set computers, complex instruction sets. It depend on the hardware. RISC is depend on the software, and it can simple, it can complex. It is a totally CISC depend on the hardware, like a Intel CPU processor. But here we are working talking about the working mechanism by the RISC. And we have also understood what is the circuit size, role of the circuit size, what is the die size. Die is the size of the particular core where we can put the chips, and if the die size is small, then we can also reduce the power consumption. And here we have and understand the what is the processor speed, what is the role of the processor speed. If the processor speed is high, that time we will find the greater performance, because it can execute multiple instructions at a particular certain amount of the time. If the CPU is working, that time there will be the heat generation. If the heat will be that time, it can damage the IC, the CPU, chipset, graphics card, anything. So we have to reduce this heat. So here you need to the cooling system. Here is a fan in our system. It can remove the waste heats, and it can transfer from the system to the outside of the system. And here we have understand the system clock. We can see the system clock, CPU perform the task, and this task when it will complete, it is managed by the system. It will take care by the system clock how much time will be taken, and how system clocks are working, how the system clock is running in particular amount of time, we'll learn in our next class. And architectural performance, here we have say instructions per cycles, and instructions per cycle work on the MIPS, and how we can calculate the MIPS by the megahertz and gigahertz. So these are things, all things we have discussed in this. And here we have discussed the live processor, Intel AMD, and we have also discussed the two types of Intel processor, 8086 and 8088. We have also discussed the overclocking of the system. There are 4 components to manage the overclocking. Why we are doing the overclocking? Because we want the greater efficiency of the systems. So students, we have discussed lot of things is topic, and I hope now you are able to understand CPU working performance. Over to Abhishek, sir.
Thank you so much, sir, for such an insightful session, sir. With your kind permission, maybe take 3-4 questions from our learners.
Okay, sir.
Sure. Now I request Mr. Hriday Goel that now you can mute yourself and you can ask your query. Hriday, just you can unmute yourself and ask your query. Pramod Singh, just you can unmute yourself and you can read.
Sir,
Yes, you are audible. You can ask.
sir, I want to say only one thing, that sir, English is not understanding properly, so I want that sir please speak in Hindi so that I can understand properly.
Okay. You want risk analysis की ना हिंदी ना?
Oh, yes, sir.
Okay बेटा, मैं तो समझाता हूँ. Now I am audible. समझ में आ रही है?
Yes, sir, बिल्कुल.
Okay. मैं तो समझा. देखो बेटा, है क्या हमारे सिस्टम में कि जब हमारा सिस्टम काम करता है, ठीक है ना, तो हमारे मॉडर्न सिस्टम में दो तरह के काम परफॉर्म करने पड़ते हैं। एक तो हमारा मेन हार्डवेयर हो गया, दूसरा हमारा हार्डवेयर वर्क करता है बेटा, आप बताओ, सॉफ्टवेयर की मदद से,
यस सर।
है ना। तो अगर हमारे पास जो इंस्ट्रक्शन सेट कंप्यूटर में, हम उन इंस्ट्रक्शन को किसी भी तरीके से रिड्यूस कर पाए, अगर हम इंस्ट्रक्शन सेट को रिड्यूस कर पाएंगे तो बेटा क्या होगा,
सर
हमारी स्पीड फास्टर हो जाएगी ना। सपोज करो कि अगर मेरे को 5 किलोमीटर चलना था और मेरे को 5 किलोमीटर चलना था और मैं उसको अगर 3 किलोमीटर में चल पाता हूँ, तब क्या होगा बेटा, अगर वही काम मैं 3 किलोमीटर में कर पाऊंगा जो 5 करना हो, तो क्या होगा बेटा,
हमारी स्पीड फास्ट हो जाएगी और टाइम कम लगेगा।
मतलब हमारी स्पीड तो वही रहेगी, कम का टाइम पर हम काम कर पाएंगे ना,
जी।
क्योंकि हम तो चल पा रहे। तो यही हमारा रिस्क करता है। लेकिन आप समझो कि हमारे पास आजकल जो सिस्टम आ रहे हैं ना, बहुत तेजी से, मतलब कहना चाहिए कि कॉम्प्लेक्स हमें काम करने पड़ रहे हैं, मशीन लर्निंग पे काम करना, डेटा साइंस पे काम करना है, हमारे पास एक साथ कई कई टास्क आते हैं, उन्हें मैनेज करना है। तो उन सबको मैनेज कैसे किया जाए, आप बताओ। मदरबोर्ड भी है हमारे पास, कोई इंस्ट्रक्शन आ रहा है, उस इंस्ट्रक्शन को कैसे डिकोड करें, क्योंकि हमारे पास क्या होता है, जब ऑपरेटिंग सिस्टम पढ़ोगे तो हमारे पास मल्टीपल टास्क एक साथ आ सकते हैं। आ सकते हैं बेटा कि नहीं आ सकते हैं?
बिल्कुल सर।
जैसे मैं करो, अभी मैं आपको पढ़ा रहा हूँ, आपको मैं पढ़ा रहा हूँ, अभी सपोज करो मेरे पास 400 स्टूडेंट्स है ना क्लास पे,
यस सर।
तो क्या मैं उन 400 स्टूडेंट्स को एक साथ पढ़ा सकता हूँ या एक साथ मैं उन्हें कर सकता हूँ क्लास में? नहीं होता ऐसा। पर हम कैसे परफॉर्म करते हैं, हम फैकल्टीज क्या करते हैं बेटा, फ्रीक्वेंसी ऑफ द टाइम, विद इन 1 सेकंड, मतलब मिली सेकंड में हम एक बच्चे की आंख से दूसरे बच्चे की आंख की तरफ देखने लगते, दूसरे बच्चे की आंख से तीसरे बच्चे की आंख की तरफ देखने लगते हैं। तो बच्चों को क्या लगता है कि मैंने सभी को पढ़ाया। ऐसा होता है ऑफलाइन में, देखा कभी कभी क्लासेस में ऐसा?
यस सर।
या आप किसी मेहमान में जाते हैं, तो आप मेहमान में अगर कहीं बैठे हैं तो हमारा जो स्पीकर होता है, तो स्पीकर क्या करता है, सभी की तरफ थोड़ा थोड़ा देखता है। तो हमें लगता है कि सारी चीजें होती, यहाँ पर भी क्या करता है सीपीयू, एक टास्क से दूसरे टास्क, दूसरे टास्क से तीसरे टास्क, तीसरे टास्क से चौथे टास्क, फिर पहले टास्क में, फिर दूसरे टास्क में, तो हमें लगता है बहुत तेज परफॉर्म कर रहा है। पॉसिबल है? नहीं है पॉसिबल। इसी कॉम्प्लेक्सिटी को मैनेज करना ये काम करता है। हमारे पास क्या होता है, कोई टास्क कहीं पर भी छूट गया, दूसरे टास्क में, दूसरा टास्क कहीं पर भी छूट गया, हम तीसरे टास्क पर आ गए। आप अगर भी पढ़ोगे पीसीबी, प्रोसेस कंट्रोल ब्लॉक,
ओके,
है ना, तो वहां पर हर सिस्टम से हर एक प्रोसेस के लिए अलग अलग रजिस्टर्स होते हैं, मैकेनिज्म होता है, तो उनको कैसे इंस्ट्रक्शंस को समझेंगे और इनको काम कैसे किया जाता है बेटा, पाइपलाइन, क्योंकि अचानक तो काम होगा नहीं। पाइपलाइंस क्या होते हैं, हमारे इंस्ट्रक्शंस का फ्लो होता है। ओके,
यस सर।
ये अपने, ये जो अपन पाइपलाइनिंग है ना, और मेन कोर इंस्ट्रक्शन जो हम कर्नल की बात करते हैं, ये रादर देन लिनक्स में ज्यादा है, किसकी जगह पर, विंडोज की जगह पर, है ना। तो ये पाइपलाइन के थ्रू ही हम भेजते हैं, और पाइपलाइंस का आप देखेंगे तो वहां पर क्या होगा, हमारे पास पाइपलाइन, क्लोज पाइपलाइन, इंस्ट्रक्शंस कैसे जाएगा, फिर वो इंस्ट्रक्शंस कैसे जाएगा, कैसे, सारी चीजें उसमें होती हैं।
The pipeline means wires.
क्या बेटा?
Pipeline means wires.
ये सिस्टम का नाम है बेटा, जैसे हमारे पास मोटरोला है ना, ये फैमिली, AMD है, इंटेल है, VAXV सिस्टम।
Okay. Okay, sir.
Now, Sukanya Arora, you can unmute yourself and ask your query. Sukanya?
Sir, am I audible?
Yes, you are audible. Please go ahead.
Sir, please explain pipelining again.
बेटा जो पाइपलाइन में क्या होता है हमारे पास, जैसे हमारे पास कोई सिस्टम में हमें भेजना है। हेलो, मेरी आवाज आ रही है बेटा?
यस सर।
सपोज करो कि हमें एक डिवाइस से दूसरे डिवाइस पर कोई इंस्ट्रक्शंस भेजना है, मुझे भेजना था A+B+C, तो ये कैसे चाहिए? जैसे मेरे पास है बॉड मास में हम लोग A+B मल्टीप्लाई बाय C, तब कैसे काम करता है ये? बॉड मास करो A+B मल्टीप्लाई बाय C, आप बताओ ये कैसे वर्क करेगा?
सर सबसे पहले मल्टीप्लाई होगा, उसके बाद प्लस।
कैसे पता चला आपको कि पहले मल्टीप्लिकेशन वर्क करेगा?
बाय बॉड मास रूल।
बाय बॉड मास रूल। और ये किसमें भी अप्लाई होता है बॉड मास रूल? सिस्टम में। ठीक है, जो पहले कैलकुलेट हुआ वो कहां जाएगा बेटा? यही जाएगा ना हमारे पास, जो हम बोल रहे हैं ना।
यस सर।
जो हम ये बोल रहे हैं, पहले कौन होगा? मल्टीप्लिकेशन कैलकुलेशन होगा, तो पहले पाइपलाइन से एक क्या चाहिए?
मल्टीप्लिकेशन।
ओके, दूसरा मल्टीप्लिकेशन, फिर क्या जाना है? एडिशंस ना।
एडिशन। यस।
अगर ऐसा नहीं होता तो क्या होता, अगर हमारे पास, अगर हम कैलकुलेट करके, और क्योंकि हमारा सीपीयू तो बहुत फास्टर है, तो प्लस वाला भी तो मैटर पहले भेज सकता है वो।
यस सर।
तो यहाँ पर तो ओवरलैपिंग नहीं होने पाए, ठीक है ना। manage the overlapping performance instructions. It go by the one by one. That time we are using the pipelining, and these are using mainly when we are performing the arithmetic operations. Okay.
Okay, sir.
What are the arithmetic operations, beta?
Some addition, multiplication, these are
Yeah,
the operations.
Sir, ask in chat box, please explain what is motherboard.
Okay. Its name itself say it is a motherboard. It is a mother of a system. How we can say it is a mother of system? Because in a motherboard we can have a RAM slots, ROMs, buses, ICs, GPU, everything is in a motherboard. So where we are putting all these things, all integrants in a motherboards. Okay.
Sir,
So it is, yeah.
Sir, one learner is asking to please explain threads and kernel.
Okay. Threads in kernel. Threads are a small programs. We already tell na कि threads are a small programs and they can perform the specific task. Okay. And the what are the first question? What are the threads? Threads are a small programs. So you have another question. How it is different from the program and why we are telling the threads? Because threads can share the same memory, same space, same code. So threads make the different from the programs. In programs, we have every program have a own space, own data. So here the threads performing the like in a kernel. If we want to program it, that have a exit, sleep. Okay, this type of work performed by the kernel, and these work performed by the particular threads, and threads are a set of instructions.
Thank you so much, sir, for insightful session. And I request you, learner, if you have further doubt, you can connect to sir on discussion forum. Please raise your doubt on discussion forum, and we will definitely happy to answer you all. Thank you all, dear learner, for your active participation, and we'll meet you all in next week. Till then, thank you so much. Happy week. Thank you. Thank you, sir.